Hello, welcome to Lesson 25, Indirect Measurement. During this lesson, we will learn how to find measurements that would be difficult to find otherwise. Before we begin, let's look at our key vocabulary word. Indirect measurement, a way of using similar figures and proportions to find a measure. So notice in the drawing, they are asking for the height of the flagpole. So what you're going to do is you're going to set up proportions. They have the man's height being 6 foot compared to the height of the flagpole. So the height of the man is to the height of the flagpole as the shadow of the man is to the shadow of the flagpole. So in the example, we have 6 is to x as 5 is to 10. Again, if you would look at the picture, the height of the flagpole is unknown, okay? But its shadow given is 10 feet, okay? Let me scoot that down for a minute. So we have a flagpole, and the height is unknown, but its shadow is 10 feet. And then we have a little guy, okay? And it tells us that his height is 6 feet, and his shadow is 5 feet. So we need to determine how tall that flagpole is. So it would be a little bit tricky to get a ladder and to climb up to the top of that flagpole. So what you can do is you can set up proportions to find an indirect measurement. So we're going to have 6 is to x. So height is to height as shadow is to shadow. So since my numerator started off with the height of the gentleman, okay, the next fraction has to start off with the shadow of the gentleman. So height is to height as shadow is to shadow. And to solve a proportion, you simply cross multiply. 6 times 10 is 60. 5 times x is 5x. And then you divide both sides by 5, and we would end up getting a measurement of 12. So this flagpole must be 12 feet tall. Okay, so 60 divided by 5 would give us 12. So we're going to practice a few problems like that. So we're going to try to find an indirect measurement by setting up a proportion. Okay. All right, so before we begin our practice problems, I'd like to look at another slide with you. Steps to finding an indirect measurement. Understand the problem, what lengths are given, what is missing. And then you would use the information given to make a proportion. So in the green box, let's read it together. Make sure to put the measurement of each figure in the same relative location in the fraction. For example, both heights should be in the numerator position and shadow should be in the denominator position. Or perhaps the fraction is set up as height is to height as shadow is to shadow. Either format will deliver the correct answer. So we're going to practice solving the problems both ways. All right, so let's look at our first problem. Number 1, a flagpole is 28 feet and its shadow is 20 feet. The shadow of a nearby tree is 30 feet. How tall is the tree? Okay, so sometimes word problems don't make sense until you draw a picture. So we've got a flagpole and we have a tree, okay? All right. So I'm going to go back to my problem. I'm going to label my picture. A flagpole is 28 feet, okay? And its shadow is 20 feet, okay? The shadow of a nearby tree is 30 feet. So the shadow of a nearby tree is 30 feet. And it wants to know how tall is that tree. Okay, so I'm going to show you 2 different ways to set up your proportion. So we could have 28 is to 20, okay? So I have the height is to the shadow as, if we come over to the tree, as the height, and we don't know what it is, but we do know that the shadow is 30. Okay, so we have height to shadow as height is to shadow. And then we just simply cross multiply. 28 times 30 is equal to 20 times x. Okay, so I'm just going to grab my calculator and I'm going to do the math. All right, so we have 28 times 30, which is going to give us 840. So 840 is equal to 20x. That's a one-step equation. You divide both sides by 20. Okay? So 840 divided by 20 would give us 42. So his shadow, the shadow that the flagpole cast, would be 42 feet. Okay? So that's one way that you can set up your proportion. I made a fraction out of the two numbers that were given for one picture. So height is to shadow as height is to shadow. Now, let's say we don't want to set up our proportion that way. Maybe we want to do height is to height as shadow is to shadow. So 28 is to x as 20 is to 30. And notice, I'm still multiplying the same numbers. 28 times 30, which would give us 840, is equal to 20x. And then if we go through and we do the math, we're still going to come up with 42. So again, 840 divided by 20 would give us 42 feet. Okay, so there's usually always two ways to set up a proportion. It's just your preference. Okay, so let's move on to the next problem. And I've made up 4 problems for us to practice. So number 2, a tree is 6 feet tall and its shadow is 4.5 feet. A girl's shadow is 3 feet. How tall is the girl? So we have a tree and a girl. So we have a tree and we have a girl. Okay, we'll give this girl some hair. So I'm going to go back to the problem and I'm going to label my picture. So a tree is 6 feet tall and its shadow is 4.5 feet. Okay, and then it also tells us that the girl's shadow is 3 feet. And it wants to know how tall is the girl. So I'm going to set up my proportion and I'm going to say 6 is to 4.5. Again, height is to shadow. I use the two numbers from the tree. Height is to shadow as height is to shadow. I don't know her height, so I'm going to put an X, but her shadow is 3 feet. And then we simply cross multiply. 6 times 3 is 18. 4.5 times X is 4.5X. So I'm left with a one-step equation. I simply divide by the number in front of the X. So I'm going to divide 18 by 4.5. And that would give us 4. So this little girl is 4 feet tall. Again, I started off by creating a fraction from the tree. You do not have to do it that way. Again, it's your preference. I could have said height is to height as shadow is to shadow. Okay? Height is to height as shadow is to shadow. Okay? Notice how I created my numerators. Height was from the tree, and then the shadow was of the tree. So if I started here, height is to height as shadow is to shadow. I could not have put 3 as my numerator. Okay, whatever you start with for your numerator, you start with for your numerator in the second fraction. And that's all a proportion is. It's setting two fractions equal to one another. All right, I would do the math, and again, I'm left with 18 equals 4.5x, and we just did the math, and we realized that the little girl was 4 feet tall. Okay, so let's move on to our third example. A house is 19 feet tall. A nearby tree is 6 feet tall with a 4.5 foot long shadow. What is the length of the shadow of the house? So this time we're dealing with a house and a tree. So those would be my two pictures. I'm going to draw a house and a tree. So we've got this house and we've got a tree. Excuse my artwork. I'm not the best drawer in the world. So we've got a house that is 19 feet tall and its shadow, we're looking for the shadow. We do not know the shadow. Okay, so the tree is 6 feet tall. The tree is 6 feet tall with a 4.5 foot shadow. So we're looking for the shadow of the house, okay? So I could start here with the house and I could say height is to height, okay? Height is to height as shadow is to shadow. Okay, so what I did? Height is to height as shadow is to shadow. Or I could make a fraction out of the house. Height is to shadow as height is to shadow. So look, even though our fractions do not look exactly the same, we still end up multiplying the same numbers on the diagonals. 19 times 4 1/2, 19 times 4 1/2. 6 times x, 6 times x, okay? So 6x is equal to 19 times 4 1/2, which is 85.5, okay? Again, you divide by the coefficient, whatever's in front of x. Okay, so 85.5 divided by 6 would give us 14.25. So the shadow of the house is about 14.3 feet if I would round to my 10th place. Okay, the 5 makes the 2 bump up a number. Okay, so we have one more to go. And the way the problem is worded makes it a little bit trickier, okay? But it's still a height and shadow problem, okay? So let's look at our last problem. Number 4. An 11-meter tall sign casts a 19-meter shadow when the shadow of a boy standing next to it is 3 meters long. To the nearest tenth of a meter, how tall is the boy? Ooh, so that was a mouthful. But I'm still going to draw my pictures. So we've got this sign, and we have a boy, okay? So we've got a sign and a boy. I'm going to label what's given. So an 11-meter tall sign cast a 19-meter shadow, okay? And then the boy, it tells us that when the shadow of a boy standing next to it is 3 meters long. So the shadow of the boy is 3 meters long. So we need to find the height of the boy. So sometimes the word problem tries to confuse you, but just reread it until it makes sense and draw a picture. So I can say height is to height, okay? Height is to height as shadow is to shadow. Or I could make a fraction out of the sign. I could say height is to shadow as height is to shadow. So notice, am I still multiplying the same 2 numbers on each diagonal? 11 times 3, 11 times 3. 19 times x, 19 times x. It's just however you want to make your fractions, okay? They have to be in the same relative location. Height is to shadow, okay? Height is to shadow as height is to shadow. Height is to height as shadow is to shadow, okay? All right, so we're going to do the math, and we're left with 33 is equal to 19x. 33 is equal to 19x. So we're going to end up dividing our 33 by 19. So 33 divided by 19 is going to give us 1.7. So this little guy is 1.7 meters tall. So to wrap up our lesson on indirect measurements, first of all, I want you to draw a picture, label the parts that are given, create a proportion, and then solve for the unknown. Thanks for watching Lesson 25, Indirect Measurements.